can type in our codes to be able to run our analysis. So first we have to import some packages. So we'll type import pandas as PD. Pandas is one of the packages that is used for statistical analysis. Let me start my kernel. I'm restarting my kernel so that it starts from 1. So I restart my kernel. Right. So import pandas as PD. So what it's doing is, so this is asterisk, it will soon turn to 1. Once it turns to 1, it means it has finished importing. Yes, so it turned to 1, it has finished importing whatever package that will help us do our descriptive statistics. Next, you have to ascribe or import the data set that we'll be using. So when you come here, I have the data set in a folder that I call Kpene over here. So I have it in this folder, Kpene, and the name is demonstration Kpene_Kpene.csv. So that is what I'm going to code. I'm just going to give it the path name. So here I'm going to say that Python should recognize that data as df, data frame. So df is equal to pd pandas. So mind you, we imported pandas as pd. So when we see pd, it means pandas. So pd.read underscore csv. So underscore csv. Then we'll open brackets and now give Python the path to the data set we are looking for. So as we saw, it is in a folder called Kpene/. When you open Kpene, it is called demonstration underscore Kpene.csv. So let's check if that is correct. So that's demonstration underscore Kpene.csv. So it's correct. So once we do that, we just click on, wow, it has given us an error. So let's see where the error is coming from. Okay, so the best thing to do is we'll copy the name rather than. So let's rerun this. Let's cut this and rerun it. So df is equal to ed.read underscore csv brackets. So instead of typing this, we'll just copy this and slash copy this. Right. So now it has worked. So it is best to copy the names as they appear over here. So it's likely when I was typing, I made a mistake in the names. So it is best, it's case sensitive when you omit some. So let's omit S here and see what happens. So we see it returns error. So let's put the S back. Right. So what it means is that we have to be very adept when it comes to typing or identifying our codes. Now, the next thing is to identify or look at how the data is looking like. So the code df.head brackets gives you an opportunity to look at the first 5 columns or rows of your data. So you press enter and then shift enter. Sorry. You press on the Yeah, shift enter, and then you have your output. So here it gives you that our data is about this, and this is the first 5 entries. So this one will help you to just visualize your data. So this one doesn't have a platform like the JASP and then the Excel, SPSS, and the rest, which we saw where we can manipulate the data there. So this is how we can be able to see what we are working with. The next is for us to run the descriptive statistics. So we call it DF, which is the data frame dot describe. We just type describe, and then you press shift enter, and then it gives you your count. So this gives us a count. It gives us the mean value. It gives us the standard deviation. It gives us the minimum. It gives us the 25th percentile, 50th percentile, which is equal to the median. It also gives us the maximum value. Now, we also want to look at a distribution aspect, which is the kurtosis and then the skewness. And before we can do that, we also have to import some packages. So we'll import from SciPy stats. So we'll type this code from SciPy.stats import skew. Okay, so the spelling mistake I made is C is SciPy, not SciPy. Yeah, not SciPy. So that's a spelling mistake. So now we have imported what will help us to calculate the skewness. So the next thing is to type in skew, and then it is our data is in a data frame, and we want a particular, we want to run it for just FBG. So we just type FBG, and then dot drop NA, and then we'll run. Seeing invalid syntax. Let's see where the error is coming from. Okay, so there's no dots. We don't have a dot over there, right? So it's good we are having errors along the line, so that it helps us to see that Python coding is one serious business. You need to really know your codes and not make mistakes. So it is painful. You run a whole lot of codes and you realize that after running, particular thing is not working as you think. It is maybe a dot that you didn't put somewhere that made you have that error. So it is good we're having errors and we are correcting it along the way. So it gives us the skew value, which is 0.52, blah, blah. Now we also want the kurtosis value. So we equally would import that. So we can just copy this. So from SciPy, SciPy start, we import kurtosis. And then the same code we are using, just that we are just changing this thing to kurtosis. Run. So yes, so it gives us the kurtosis value. So basically, this is how we can run it for all the variables to get their various skewness, kurtosis, and descriptive measures. One advantage of Python is that you can use it to run codes that would back platforms like online platforms. So that's one advantage Python and R has over the other statistical packages. And most programmers would prefer to use Python and R in their analysis than the other platforms, because of the leverage it gives one in supporting the back end of whatever. So it is, I remember some time ago when I ran a code that helped to predict the default rate of children under 5 to immunization. And my model was about 95% good at predicting whatever. And we use Python in that coding because we are going to use it to back an app. And if we use SPSSM, it wouldn't make sense to do that. So yes, that is one advantage the Python platform has. So all too soon, we have been able to see how the various platforms